Hello, my dear students. Today we are going to see the topic for CET class is gravitation, mechanical properties of solid and fluid. As you have already gone through many synopses, just we will go and see few of the concepts in the synopsis, which you have already have. Okay. First one is Kepler's law. In the concept called gravitation, Kepler's law. Kepler's law deals with the planetary motion, laws of planetary motion. What does the Kepler's first law states? Kepler's first law states that, what does it state? First law states that all planets move in an elliptical orbit with the sun at one foci. Second law states that the line joining the sun and the planet sweeps equal area in equal intervals of time. Correct? Then, square of the third law states that square of the time period is proportional to the cube of the semi-major axis. So, these are the three Kepler's law. That is, first one, all planets move in an elliptical orbit with the sun at one foci. That is, this is the elliptical orbit with the sun at one foci. Then, the line joining the planet and the sun sweeps equal area in equal intervals of time. Third one is, square of the time period is proportional to the cube of the semi-major axis. Next is Newton's law of gravitation. In Newton's law of gravitation, the force between the two bodies is proportional to what? Force of attraction is equal to G m1 m2 divided by r square, where G is as gravitation universal constant, m1 m2 are the masses of the two bodies, r is the distance between the two particles. So, this is about the Newton's law of gravitation. The gravitational force of attraction between the two bodies is proportional to the product of their masses and inversely proportional to the square of the distance between them. The next concept which we are moving for is about the acceleration due to gravity. Expression of the acceleration due to gravity is equal to Gm by r square. Either you can write capital letter R or small letter r. Yeah, I think you have gone through capital letter R. Okay. G is universal constant. M is mass of the earth. R is the radius of the earth. So, acceleration due to gravity, G is equal to Gm by r square. The next concept is, if we are standing at some height from the earth's surface, if this is the earth, we are standing at a height from the earth's surface h. Then acceleration due to gravity at this height or altitude is G dash is equal to G divided by 1 plus h by r the whole square. G dash is equal to 1 plus h, G dash is equal to G by 1 plus h by r the whole square. That is for the person standing at some height. If a person is standing below the earth's surface, if this is the earth's surface and if it is standing below the earth's surface somewhere over here, then if the depth is d, then acceleration due to gravity at that person is G dash is equal to G into 1 minus d by r. G into 1 minus d by r. This is the expression for acceleration due to gravity at a depth d below the earth's surface. Next, gravitational potential energy associated with the two particles. What is the expression for the gravitational potential you have learnt? Expression for the gravitational potential you have learnt is V is equal to minus G m1 m2 by r. V is equal to minus G m1 m2 by r. This is expression for gravitational potential energy. V is equal to minus G m1 m2 by r, where G is universal constant, m1 m2 are the masses of the two particles, r is the distance between the two particles. So this is about the gravitational potential energy. The next is escape speed from the Earth's surface. Escape speed from the Earth's surface, VE is equal to, the expression is square root of 2gm divided by r. Or else we can write it as square root of 2gr, because gm by r square is equal to small letter g. So we can write V is equal to square root of 2gm by r, or it is equal to square root of 2gr. These are the two expressions for escape velocity. Then the next expression is for orbital speed of the satellite, that is equal to square root of gm by r, or it is equal to square root of gr. These are the two expressions for the orbital speed of a satellite which is revolving around the Earth in a circular orbit. Then one more is, what is the escape speed of the Earth? It is equal to 11.2 kilometer per second. Escape speed is 11.2 kilometer per second. The next concept which we are moving for is time period of the revolution of the satellite. What is the expression for the time period of the revolution of the satellite? Time period of the revolution of the satellite, the expression is T is equal to 2 pi root r cube divided by gm. 2 pi root r cube by gm. So this is the time period of the revolution of the satellite. Then energy of the satellite of the mass m, energy is equal to minus gmm divided by 2r. This is the expression for the energy of the satellite which is revolving around the Earth in a circular orbit. If suppose this is revolving at some height h, then I can write r plus h in this place from the Earth surface, above the Earth surface, then minus gmm by 2 r plus h. Same way over here also, if the orbital is revolving with some height, then it is r plus h. So this is expression for the energy of the satellite which is revolving around the Earth's surface. The next concept which we are moving for is about the mechanical properties of solid. So what we have completed till now is about the gravitation. There are still more concepts. Please go through. We are not going in deep now. Just summaries of that topic we are discussing about. Now we have discussed about the gravitation. The next concept we are going to discuss about the mechanical properties of solid. About the mechanical properties of solid, the stress is nothing but restoring force per unit area. Restoring force per unit area. Then stress is of three types. There are three types of stress: longitudinal stress, tangential stress, and bulk stress or hydraulic stress. So there are three types of stress, that is longitudinal stress, tangential stress and hydraulic stress. So unit of stress is a force per unit area, so Newton per meter square, or it is a Pascal. Anyone, either Pascal or Newton per meter square. So this is about the stress. Next, strain. It is a fractional change in dimension. Fractional change in dimension. There are three types of strain. That is first one, longitudinal strain, volume strain and shearing strain. Longitudinal strain, bulk strain, and tangential strain or shearing strain. So there are again, strain is divided into three types: longitudinal strain, bulk strain, and shear strain. Longitudinal strain is also called as tensile strain, and volume strain or bulk strain, whereas shear strain. Next, the concept which we are moving for is Hooke's law. Hooke's law states that stress is proportional to strain. So I can say stress is proportional to strain according to Hooke's law. Very, very important law, and I can say stress is equal to strain with the proportional constant K, where proportion is nothing but modulus of elasticity. K is nothing but modulus of elasticity. The next concept is about, there are three types of modulus of elasticity, that is Young's modulus, bulk modulus, and rigidity modulus. Bulk modulus and rigidity modulus. Young's modulus. In case of Young's modulus, it is nothing but ratio of longitudinal stress to longitudinal strain. Longitudinal stress to longitudinal strain. Longitudinal stress is force per unit area. Strain is delta L by L. Longitudinal means it deals with the concept of length. So longitudinal stress by longitudinal strain is nothing but Young's modulus. So Y is equal to F by A into delta L by delta L, or F by A divided by delta L by L. The next one is bulk modulus or shear modulus. Bulk modulus. Bulk modulus is nothing but B is equal to F by A delta V by V. Bulk modulus deals, it is nothing but B is equal to stress divided by strain in terms of volume. Volume strain it is. Next, rigidity modulus or shear modulus. Rigidity modulus or shear modulus is given by eta is equal to F by A theta. Eta is equal to F by A theta. If this is a body, it is pulled and there will be some change in the angle, that is theta. That is, if it is pulled by a force F, there will be change in the angle theta. Then eta is equal to F by A theta, or else it is F by A delta L by L. You can also write rigidity modulus as F by A delta L by L. So this is about the shear modulus or rigidity modulus. Then the energy stored in the stretched wire is, the expression for the energy stored in the stretched wire is E is equal to, or U is equal to, we give U is equal to half into stress into strain. Half into stress into strain. This is the expression for the energy stored in a stretched wire, that is half into F into delta L expression. So energy stored per unit volume. If it is not a per unit volume, this should be into V, volume. We always speak about energy stored per unit volume is equal to 1 by 2 F into delta L, where F is the force, delta L is the change in the length. So these are the expression for the energy stored in a stretched wire. So we have learnt in this chapter, when we see it is a stress and strain relation, modulus is divided into three types: Young's modulus, bulk modulus, and rigidity modulus. Their expressions very, very, very important. Then energy stored expression is very, very important. The next concept which we are moving for here is the properties of fluid, mechanical properties of fluid. In the mechanical properties of a fluid, initially we speak about the thrust, pressure. So thrust is nothing but average pressure. Average pressure is equal to force by area. The thrust is nothing but force per unit area. When we speak thrust, actually thrust is nothing but force. So average pressure applied in a liquid is force by area. For what is that? For pressure is nothing but force we apply for that particular area. Then we are going to speak about the in case of gauge pressure, expression for the gauge pressure is P is equal to PA plus rho GH. P is equal to PA plus rho GH. PA is the atmospheric pressure, rho density, acceleration due to gravity, and H is the height. Will give you the value of pressure, hydraulic pressure or the gauge pressure. Then we speak about the Pascal's law. Pascal's law, what it states? Can you help me? This is very important. Pascal's law. A change in pressure applied for an enclosed fluid is transmitted equally in all direction undiminished. When we apply a small force or pressure at one region in an enclosed fluid, then it is transferred equally in a whole liquid, undiminished. If we press here, everywhere the pressure is transmitted equally. So that is nothing but about Pascal's law. Next is about the incompressible fluid. The volume of the incompressible fluid, you should know that AV or VA is equal to constant. What is that VA is equal to constant? Volume, if the fluid of volume velocity V, if we having a fluid of velocity V moving with the area of cross section A, then velocity into area of cross section should be equal to constant. So for a incompressible fluid moving in a volume of the incompressible fluid passing through any cross sectional area per second is steady. So it should be steady. Volume of the incompressible fluid in any cross sectional area is steady. That is VA is equal to constant. Velocity into area of cross section which should be equal to constant for an incompressible fluid. Next, according to Bernoulli's principle, what it says, the streamline flow, for the streamline flow fluid, the sum of the pressure P per unit volume plus kinetic energy per unit volume half rho V square plus potential energy per unit volume is equal to constant. What it says, according to Bernoulli's principle states that for a streamline flow, pressure per unit volume, kinetic energy per unit volume, sum of pressure per unit volume, kinetic energy per unit volume and potential energy per unit volume should be equal to constant. This is nothing but which law? Bernoulli's principle. It is Bernoulli's principle. Then we will move towards the Stokes law. Stokes law states that, what it states, the force on the sphere F is equal to 6 pi eta AV. Force on a sphere of radius r moving with the velocity v in a fluid is F is equal to 6 pi eta AV. This is the expression which you have used in the experiment. Remember that experiment with the sphere what you have done. That is F is equal to 6 pi eta AV. Then we move toward, this is nothing but Stokes' law. Which law it is? Stokes' law. After the Stokes' law, the next concept what we are moving for is about the velocity, terminal velocity. When the sphere reaches at the end, what is the expression for the terminal velocity? This expression actually you have used in your experiment, that is 2r square rho minus sigma into g by 9 eta. 2r square rho minus sigma g by 9 eta, where rho is the density of the sphere, sigma is the density of the fluid, eta is nothing but terminal velocity, r is the radius of the sphere. So these are nothing but this expression for the terminal velocity. See, this expression and all very, very important in solving problems. This one, this whatever is discussed in today's class, these are the few of the topics which are very, very important in solving the problems in your CET. CET, we will always go through these NCERT textbooks. The question will be based on the NCERT textbook most of the times. And it will not go beyond NCERT. Next, we will be speaking about surface tension. Surface tension is nothing but force per unit length. So, force per unit length. Acting tangential to the surface. Acting tangential to the surface. Then surface energy is equal to surface tension into area of the surface. Surface energy is equal to surface tension into area of the surface. This surface tension expression, surface energy expression, these are very, very important. Okay. The next is about the capillary tube. The tension of the liquid in a capillary tube. What is the expression for the tension? Tension in the capillary tube is T is equal to half rho g h r by cos theta, where rho is the density of the liquid, then capillary tube of radius r, g is acceleration due to gravity, h is the height raised in the capillary, theta is the angle of contact. So T is equal to half rho g h r by cos theta. This is the expression for the tension of the liquid in a capillary tube. Next we will be speaking about is excess pressure inside the spherical drop. Spherical drop. We will be speaking about the excess pressure in the spherical drop, that is R. Excess pressure P is equal to R, 2T by R, where R is the radius of the liquid drop. Excess pressure in, we are speaking about excess pressure. Expression for excess pressure for a spherical drop is P is equal to 2T by R. Expression for the excess pressure inside air bubble. Next is inside the air bubble, P is equal to 2T by R. It is same. Inside the spherical drop and inside the air bubble, the expression for the excess pressure is one and the same. But for a soap bubble, inside the soap bubble, expression for the pressure is, excess pressure is P is equal to 4T by R. Expression for the excess pressure inside the soap bubble is 4T by R. There are few more formulas and expressions to be discussed, but I hope you will go through on your own. And when we solve some more problems, when we solve many problems, what he has already given to you, those problems when we solve, we will go through some more formulas, we'll discuss some more formulas and concepts. Okay. Now we have generally summary we have taken of the gravitation, mechanical properties of solid and mechanical properties of fluid, and we have completed the concepts in general way. So please learn for your CET properly. Within few days you are going to go through the CET examinations, right? Okay. Next we will move for the synopsis. We'll move towards the problem solving. Okay, MCQs. Thank you.